day, students. You're welcome to Eko Learners Support for WAEC and NECO candidates. I am going to be your physics instructor for today's lesson. Come along with me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Fiber optics is the topic we'll be treating today. Let's check the learning objectives. By the end of the lesson, you as a student will be able to describe fiber optics and state its principles. State the components and types of fiber optics. Lastly, you should be able to state the advantages and application of fiber optics. An optical fiber is a flexible glass or plastic fiber that can transmit light from one end to the other. Such fibers find wide range usage in fiber optics communications, where they permit transmission over longer distances and at higher bandwidth than electrical cables. That's the diagram over there. What are the principles of fiber optics? Optical fiber works on the principle of total internal reflection. When light ray strikes at the internal surface of optical fiber cable core, such that incident angle is greater than critical angle, then incident light ray reflects in the same medium and this phenomenon repeats itself. As you can see from our previous diagram, this is the core, and when there is total internal reflection, the incident ray we see is reflected and we see all the rays surrounding from the other optical fibers. And the repetition continues. The following materials are used in making fiber optics: the glass in fine strands, polycarbonates, Teflon sheets, sapphire, and silica. There are two types of fiber optics. We have the multi-mode fiber, denoted by MM, which has a large core and allows for multiple parts through the fiber. And we have the single mode, which is denoted by SM, single mode fiber, which has only one part through a much smaller core. Those are the two types of fiber optics, and they have their uses. We said, even from the name, multi-mode, single mode. So definitely the multi-mode is going to allow more passage of light, while the single mode is just going to be just through a smaller, because it has a smaller core, it's just going to be a singular part. The components of fiber optics, like we said, we have the cladding, we have the coating, we have the core, like I showed you previously, and we have the outer jacket. But you will not see all this. You will only see the cable itself, but you are only seeing all the inner one because it has been cut for us to see all the components in it. So we have the core, like I said, this is the core here. The cladding, this is the cladding. The cladding is the one protecting the core. Then we have the coating. The coating protects the cladding and the core. These elements carry data by way of infrared lights, thus propagating signal through the fiber. Uses of fiber optics. Like we mentioned previously, usage of internet, computer networking. It's also used for remote sensing, for either you use usage of the drone, you need to, in case of kidnapping, you understand, it senses, it goes further, and even deep down in the ocean, it also works. Automotive industry, that is making of vehicles, surgery and dentistry, just like we see in the diagram. This is a doctor, a surgeon performing surgery using optical fiber. Then we have, it's also used in decorations and lightnings. When you go to your parties, you even see it on some buildings. It's fiber optics that is used then for telephone. Imagine you are making long calls without any breakage or miscommunication. Fiber optics travel faster, like we read in one of the principles, and also for our cable television. which we all know where it's from, all the way from South Africa, and it is being viewed all over. Application of fiber optics, like we said, is used in the medical industry, like we saw the surgeon the other time, communication, our long calls or short calls, defense, the military, they use it, and also in industries. It's also used in industries and for broadcasting, lighting and decoration and mechanical inspection. And it's also used for mechanical inspections. So when you check the back of your decoders in your houses, you should be familiar with all these cables. So they use fiber optics because it's lasting and it's better than copper wire. What are the advantages of fiber optics compared to copper cables? Like I said earlier on, fiber optics cables are thinner and lighter in weight. You can see the difference. This is for fiber and this is the other one. They are thinner and lighter in weight. That's the first advantage. Then fiber can also withstand more pull pressure than copper. That is why they use it for all this, our cable. When you have your antenna up wherever it is, they can easily drag it and pass it through where you need it to get to. Fiber optics is less prone to damage and breakage. Fiber is flexible and can bend easily compared to copper. Fiber can resist most corrosive elements that often attack, such as copper cables. So these are the differences and the advantages of fiber over copper cable. Our practice question. State 3 advantages of fiber optics. Question 2. List 3 applications of fiber optics. I'll be right back for your answers.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
You're welcome back. So I believe during the course of the lesson, you have the answers to these questions. Let's check it together. State 3 advantages of fiber optics. The first answer is fiber optic cables are thinner and lighter in weight. They can also withstand more pull pressure than copper. The third advantage is that fiber optics is less prone to damage and breakage. And finally, fiber is flexible and can bend easily. I hope you got the answer. Let's go to the second question. List 3 applications of fiber optics. So, the first answer is used in medical industry, is used in communication, is used in defense, is also used in industries and in broadcasting, lighting and decorations, mechanical inspections. So any of this answer you choose is the correct answer. And I believe you have done justice to that.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For any other question, comment, observation, kindly contact us through the link of our social media posted on the screen. Thank you. See you next time.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Good day, students. You are again welcome to Eko Learners Support for WAEC and NECO candidate. I'm going to be your physics teacher today, and we'll be considering the topic alternating current. Let's go ahead to see.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Alternating current. Alternating current. What are our objectives today? At the end of today's lesson, you must be able to define a capacitor. Similarly, you must be able to explain the reactance of a capacitor. And lastly, you must be able to explain phase difference with capacitance and to solve problem on it. Let's go. What is a capacitor? A capacitor is an electrical device for storing charges or energy. I reiterate, a capacitor is an electric device for storing charges or energy. It has the symbol. You need to know the crystal difference between the symbol of a capacitor and a cell. Very, very important, because that is a rife. It's a global symbol. It's of the same height, unlike that of cell, which is one long and one short. Please note that crystal difference. The two of them are of the same height. That is a capacitor. Now, having said that, there are two types of reactance: capacitive reactance and inductive reactance. Today we'll be considering capacitive reactance, or otherwise called reactance of a capacitor. Is defined as opposition in ohms of a capacitor to the flow of alternating current. Opposition in ohms of a capacitor to the flow of alternating current. Don't forget, when we say opposition, it's also functioning in terms of resistance. A resistor is also, in terms of DC, is an opposition. It works against the flow of current. But here we are talking in terms of capacitor. So it is denoted with X subscript C. And by formula, X subscript C equals to S subscript C equals to 1 over angle C, and our angular velocity is 2 pi f, so it becomes 1 over 2 pi f c. Now, similarly, from what we have known in SS1. That is Ohm's law. Ohm's equation says V equals to IR. But we are not working in terms of resistance. We are working in terms of reactance of an inductor. So which replaces the resistance. So that means the equation we turn to V equals to IX subscript C. And so from there, that's what we have here. So our S subscript C will now be V over I. Now that's what we have here. We have V and I. Voltage and current are either in peak or in root mean square value. This is the symbol for a capacitor. You can see it. And this is the symbol for an AC. You have the graph. Phase difference with a capacitor. Phase difference with a capacitor. Now you can see we have the voltage and we also have the current. Let's go back to our GSS or SS1 work. Under mathematics, we have the graph, the y-axis, which is vertical, and the x-axis, horizontal. Now, look at this graph. We're having our y-axis positive, y-axis negative, and we're having our x-axis here. Look at, we're having two graphs plotted, two waves. The current, which is of the capacitor, and we have the voltage of the capacitor. Looking at it, look at it. As at this place, now the current here is 180. Considering sine waveform under mathematics, 180. Now look at it there. This is 180. When the current is 180 here, the value of voltage is just still as 90. In other words, when it moves and may become 270, the voltage is now at 180. As at that time, this one is at 270. In other words, In other words, I is leading on V by 90 degrees. I leads on V by 90 degrees or cycle over 4 because a cycle is made up of 360 degrees. So current leads on voltage by 90 degrees for phase difference with a capacitor. Unlike phase difference with an inductor. For an inductor, V leads on I by 90 degrees. Please, we need to know the difference. Very important. It's just like word and opposite. For inductor, phase difference, V leads on I by 90 degrees. But for capacitor, phase difference with the capacitor, I leads on V by 90 degrees. Which, in other words, you can also rephrase your statement by saying V lags, is lagging behind, lags on I by 90 degrees. Now let's look at these examples together. A capacitor of 2 microfarad in a radio circuit has a current of 4 milliampere RMS, root mean square value, with frequency 1000 Hz in its circuit. Find A, the reactance of the capacitor. The reactance of the capacitor. The reactance of the capacitor. Look at the solution. We have been told that X of C equals to 1 over C, and it becomes 1 over 2 pi FC. So we are asked to calculate the reactance. You have been given the frequency, and we also been given the capacitance of the capacitor. Look, you need to know one thing. You are given your capacitance in microfarad. And 1 microfarad equals to 10 raised to power minus 6 farad. So it's very, very important that you incorporate it. And that's what we are having. So we are having 1 over 2 times pi times frequency, which is 1000, then times, what is our C? 2 times 10 raised to power minus 6. That's what we have here. When you do it, at the end of the day, you have your reactance of a capacitor or capacitive reactance equals to 79.37 ohms. The symbol, put the symbol there, 79.37 ohms. That's the answer. Yes, haven't done all. Then, let's see. I'm going to give you question to practice. Let's look at the question now. Look at this question. At what frequency will a 20 microfarad capacitor have a reactance of 500 ohms? Again, at what frequency will a 20 microfarad capacitor have a reactance of 500 ohms? Having done all, I believe strongly that you're going to do justice to this question. However, I'll be right back in a minute. After you must have done justice to them, we'll look at it together. I know within me that you have done justice to it. However, let's look at it together. At what frequency will a 20 microfarad capacitor have a reactance of 500 ohms? Solution. What are the data given? For you to understand it, write out your given data. Number one, we are given a capacity. We are given a capacitor of 20 microfarad. We are also given reactance, capacitive reactance, that is S subscript C equals to 500 ohms. What are we asked? At what frequency? We are asked to look for frequency F. That is unknown. Please, it's very important. With this, you'll be able to know how to go about it. Then having said that, let's substitute our formula. Very, very important. In physics now, the first thing you do, you put down your formula. That one will give you the direction of where to follow. Based on what we have there, our x subscript c equals to 1 over 2 pi fc. So we are looking for f. That means we make f the subject of the formula. So making f Then we have F equals to 1 over 2 pi x subscript C, C. Can we move to this side? Then we have our F equals to 1 over 2 times pi times x subscript C, that is 500, times what is 20 times 10 raised to the power minus 6. Why am I doing that? Because we have to convert the microfarad to farad. And like I told you, 1 microfarad equals to 10 raised to the power minus 6. Just like 1 kilo equals to 10 raised to the power 3, which is 1,000, the same thing. So let's do justice to that one after the other. We have 1 over, now 2 times 500 will give us 1,000. So 1,000 times 20 will give us, that is 1, 2, 3, 4 times pi times 10 raised to the power minus 6. So I have 1 over, I'll convert this so that it can easily done for me. It's the same thing as 2 times 10 raised to the power 4 times pi times 10 raised to the power minus 6. 10 raised to the power 4, 10 raised to the power minus 6 will give me. That means I have 1 over 2 times 10 raised to the power minus 2 times pi. I'll bring this one up. It will give me 100. So I have 100 over 2 times pi. I have this, so I have 50 over pi. So my final answer. Let me use my calculator. So final answer 15.91 hertz. 15.91 hertz. I believe that you also got that answer. If not, go over it and check it again where the missing answers or missing points are, and do justice to that.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For any comment, questions, or observation, contact us on our social media that will be displayed on the screen. Until I come your way again, stay blessed.